Hello, so this is Warren from Apollo Tech Support once again. We're just going to do a series of videos on intrinsically safe equipment, and this particular setup we're looking at here is conventional Orbis I.S equipment. So intrinsically safe devices would be used in areas that are classed as hazardous under EN 679 and under a fire risk assessment. The areas typically will be places such as petrochemical stations, maybe. They might be at the least down to places like paint stores, adhesive stores, places where you keep chemicals maybe. And basically the devices are built in such a way and certified so that they won't spark or overheat and cause an explosion in an environment where there's dangerous gases and chemicals that could be ignited. So in most of those areas, obviously, most of the electrical equipment will be either flame-proof or intrinsically safe. Intrinsic safety actually gives you the highest degree of protection in the most hazardous areas. So these devices are conventional, and it might be running from a conventional control panel. We'd always recommend a dedicated zone for your Orbis I.S devices if you're using them. And in this particular occasion, we're running from a zone monitor unit. So you can see the zone monitor unit is one of our interfaces that we've got connected to our loop tester at the moment. So we've got an analog value of 16. Everything's normal in this circuit, and our zone monitor unit, which is here, has got an address, and that's made on a label which is underneath the label there in the gaps, and it can be anywhere between 1 and 126. In this case we're just at address 1, and we've got our wiring coming from the loop tester and going into our zone monitor unit on this side. It comes out from the loop zone monitor unit, so typically you'd have about 24 volts here from the loop. Usually on this side we've got about 19 volts after it comes out of the zone monitor unit being fed into a barrier, and Apollo don't actually make barriers, so we use standard off-the-shelf barrier, and this one's from a company called Pepper and Fuchs. You can see on the barrier, I know it's upside down, but that's the barrier there, and the blue connections from the barrier will come out to our hazardous area devices. Now typically these would obviously be away out on the in the hazardous area. In this case they're just attached to my demo board, so just so we can show you how they operate. So this is our Orbis I.S device, and any I.S devices will have writing on the detector and device which signifies its hazardous area classification. So you can look up all that information on engineering guides. This case we've got a multi-sensor unit, which is an optical heat detector, and you can just get an optical smoke detector in the Orbis I.S range, or you can get various heat detectors going from about 57 degrees up to about 90 degrees, either with or without a rate of rise, depending on the device. We've also got a I.S manual call point, conventional. This doesn't have an LED, and it's all certified to be used in the hazardous area. So and obviously what you see on the device there, you can see the LED flashing away on the Orbis I.S device, and that is just to show us that the device is in startup mode and it's working and everything's fine once we've wired up the the connections in the base there. So it's just coming from the blue connection of the barrier in and out of our Orbis I.S base, and then on to our manual call point. And also in this mode we could do a fast test on the device while it's flashing quite quickly, and that device would go into alarm much quicker than normal. It normally has transient rejection built into it, which is false alarm immunity that helps it be resistant against exhaust fumes and things like that. It's also got drift compensation. So the drift compensation means the build-up of dust and dirt inside the device doesn't affect the sensitivity of the detector. It remains as sensitive as when you first put it in until it has too much dust, and then it will signify that the drift compensation limit has been reached by flashing a yellow LED instead of a red LED. And obviously, if you get an alarm on this circuit, so if we set the call point into alarm, you get an analog value of 64 from the zone monitor unit, and the fire LED will be on the zone monitor, and obviously we get our alarm condition. The bells and sounders would be going off on the main control panel. If we remove the device, obviously fire overrides fault, but as you saw earlier, when we remove the device we get a fault condition on the circuit because we have an end of line resistor at the end of the detection zone. So that's our Orbis I.S product. Please keep your eye out for more I.S videos coming along.